We are now in the design to operate process in the main production phase. Here, we will be manufacturing a double-seat valve. We showed two plants, a supplier's facility that pre-assembles the control head, and we also see the main plant that carries out the final assembly of the valve at the end. The planning from SAP S/4HANA now for the first time meets reality. So we have to check if all our machines are available and if all our workers are on hand today. To do this, we use SAP Digital Manufacturing Cloud, in particular the Resource Orchestration solution, which gives the shift supervisor an overview. As soon as the production order is released, the worker receives all the information needed to carry out the work at his workstation. This includes the special product configuration to be manufactured, plus visual work instructions to precisely guide the work at this station. The showcase here also shows how you can support the worker with eye control, particularly at workstations where the worker may already wear gloves or carry tools, making the use of a mouse or keyboard difficult. All the process data is stored in the control head's digital twin and is made available in the SAP Asset Intelligence Network for documentation, traceability, and information about the equipment. Now it's time to manufacture our final product. An important principle here, now all subsequent processes are linked to each other down to the automation level. The customer first configures and personalizes a double-seat valve here. In our case, this will be a text that we print on a nameplate. Once the customer has created the order in the e-commerce system, it is in the ERP system and a production order is released and sent to production. This demonstrates how the information flows from the customer's order down to the final machine. Once our nameplate has been manufactured, we need to summon an autonomous transport vehicle to send it on its way. As a mobile workbench, the vehicle moves fully automatically to the warehouse and picks up the order-specific components to be assembled. The fact that we are using LTE technology, that is, wireless networks to control the vehicles, has several interesting aspects. From an infrastructure perspective, I have extremely fast response times. This is interesting because I can monitor and order the vehicles at any time. On the other hand, it is also a very simple installation. Once the components have been picked up, the mobile workbench automatically selects the ideal workstation for assembly, following the logic of the dynamic process control. With personalized, configured products, it is of course very important that each product is mounted differently. So the worker must be optimally supported in order to ensure best quality of work. With projections on the workstation, the system shows the correct assembly sequence, which parts have to be picked up, and where they have to be mounted. It also projects written work instructions. After the assembly, we come to the quality control, representative for various subsequent processes in real companies. If everything is okay there and the finished product is ready for delivery, it is stored in the warehouse again until the colleagues from logistics say, now the truck is ready to deliver the end product to the customer. We use the colorful bouquet of SAP technologies. For example, SAP Plant Connectivity is the software layer, which talks in the direction of automation using OPC UA as the communication architecture, and also takes over orchestration, saying, for example, when vehicle arrived occurs, then activate the RFID reader to read the tags. In addition, we have the SAP Manufacturing Execution Solutions, ME and MII, as well as visualization, that is, the KPIs, which are key for any decision. Many factors which are actually classic SAP entities are now used to make decisions very close to the production, very close to automation, ready for any change at any time at very short notice.